Hello and welcome to this recorded session on reducing the area of the circular segment. In this session, we'll be exploring the concept of the circular segment and how to calculate its area. What is the circular segment? A circular segment is a region bounded by a chord and an arc. This is the circular segment as you see here. To calculate the area of the circular segment, we need to know the radius of the circle and the length of the chord that bounds the segment. Now I encourage you to be focused and engaged throughout this session, and I will be presenting some questions for you to pause the video and try to answer on your own. Once you have answered, resume the video to check your solution against mine. By doing this, you will be able to deepen your understanding of the topic and build your problem-solving skills. Let's get started. Before we start deducing the rule, I want to get the area of this triangle. So the area of the triangle ABC equals, as you know, it's a half multiplied by base, which is BC, multiplied by the height, which is AB. If we want to find sine B, sine is the opposite over the hypotenuse. The opposite is AD, and the hypotenuse is AB. We can find AD from this relation. So AD equals, do cross multiplying, AD equals AB multiplied by sine theta. Let's go to the area of the triangle ABC again. The area of the triangle ABC equals half multiplied by BC multiplied by AD. We can write, instead of AD, you can write this relation AB, AD equals AB multiplied by sine theta. So substitute AD, AB sine theta. So the area of the triangle will be equaling to half BC multiplied by, instead of AD, I'm going to write AB sine theta divided by AB sine theta. And this rule is an important rule we use to find the area of the triangle if we know the length of two sides. So here, the area of the triangle, we have reached to the area of the triangle is half multiplied by AB multiplied by BC. They are two adjacent sides in the triangle. And multiplied by sine theta, sine B, the angle included between them. So to find the area of any triangle, look here, we have a triangle like this one. It's A, B, C. We can find the area of this triangle. It's a half. We can take this side, AB here, multiplied by AC, multiplied by sine A. So it's half multiplied by the product of two adjacent sides, AB multiplied by AC and multiplied by sine A. That's the area of the triangle. How can we find the area of the circular segment? Look here. Here we have a circle, and here it's a circular segment, and this circular segment is bounded by an arc and a chord. Let's construct two radii, here R and R. To find the area of the circular segment, the area of the circular segment, it will be equal to the area of the circular sector. Here is the area of the circular sector. This is the circular sector. I'm going to color it in black. Here is the circular sector. Okay. So it will be the area of the sector minus the area of the triangle, which colored in green, minus the area of the triangle. Okay. So it will be equal to the area of the sector minus the area of the triangle. Okay. The area of the sector from the previous lesson, it's a half theta radian multiplied by r squared. And we deduce that the area of the triangle, it's half the product of two adjacent sides. Here we have radius and radius. And here this angle is theta. So we can say it's half multiplied by r, and then sine the angle included between them, sine theta. So we can tidy it up. It's half theta radian, r squared minus half r squared sine theta. We can take half r squared as a factor. So it's half r squared. Then you are left with theta radian minus sine theta. Pay attention that here theta radian measured in radian and this angle measured in degrees. And this angle measured in radian. That is the rule we use to find the area of the circular segment. It's a half r squared multiplied by theta radian minus sine theta. So what we need to find the area of the circular segment. We need to know the length of the radius and we need to know the angle. That's it. The radius of the circle, the radius. We need to know the radius of the circle. And we need to know the angle, theta. We need to know the angle measured in radian and the angle measured in degrees. And as you know, if we have x degrees and we need to get theta radian. Theta radian equals what? Equals x degrees, the angle measured in degrees, multiplied by pi over 180. And if we want to find x degrees, so it's theta radian multiplied by 180 over pi. That's it. The focus of today's session was in deducing the rule, but in the next episode, we will be answering some questions. So stay tuned for that. See you in the coming episodes. Goodbye.